So this is 3.3 common factors of a polynomial. In algebra tiles, we have three different tiles. We have our kind of x squared block, our x long tile, and our 1 unit tile here. So if we are looking at 6n plus 9, we are looking at 6 of these. I'm stacking them like this because I'm preemptively thinking about how I'm grouping these in equal patterns. And then I will have 9 of these because I have to fill the space. I have to kind of make it a complete rectangle. And let's kind of see that here with the 4c squared. I have 4 of these. So 1, 2, and 3, and 4. Then I have 6 long tiles. And when I look at these, when I'm all done drawing, I can see that these can be split into equal groups. There is 3 equal groups on A, 2n plus 3. So there's 1, 2, and 2, 3. And then over here in B, we can see that we have 2c squared plus 3c there. So it kind of factors it down. And this can even be factored a little bit farther. You can take out the c, and then you get 2c plus 3. But that's another step we'll worry about at a different time. We're going to factor 5 minus 10x, that should be an x, minus 5x squared using algebra tiles, and we're going to verify it's correct by using greatest common factoring. So let's look at it this way. There are 2 sides to an algebra tile. Let's denote that our red tile is our negative tile, so I need 5 of these negative x squared guys. Now, I have 5 distinct groups. I'm going to try and make them equal. Okay, so now I have negative 10x. So I have a long and a long, and I'm doing it this way because I want to preemptively think about ordering them such that they're equal. So now I have 5 of these gone. I have 5 more to go. I know this is going to work out. So that's negative x's, and then I also have 5 positive 1s. I'm going to just use black for that. Then if I look at GCF factoring, I have negative 5x squared minus 10x plus 5, and I factor out a negative 5. I get x squared plus 2x minus 1. Now that doesn't quite look at what we have over here on the left. And why is that? Well, that's because I took out a negative 5. If I only took out a 5, so we will go like this to make it match, I would have negative x squared minus 2x plus 1. And now we see that it matches. However, I want you guys to get into the habit of always removing the greatest negative factor because we want this guy to positive. Because it makes it easier for factoring down the road. Sometimes we will have polynomials with more than one factor. We need to look at the greatest common factor for all of these. So if I look at my GCF of negative 12, negative 20, and negative 16, I totally factor tree and look at it. You could test value. I look at this and I know that it should be 4. And it's going to be negative 4 because all of these are negative. We should take out negative 4. Now, what is my smallest power of x? I have an x cubed, an x, and an x squared. Well, I'm going to take out an x. and then my smallest power of y is a y. So then this should look like 3x squared plus 5y plus 4xy. These ones, go slow. Take your time. Okay? That's it. Head off onto the assignment.